All right, recording is rolling. It's Tuesday, January 26th. So I'll take you guys through lesson 8.3 today. Of course, I have recorded a video that's over an hour long. It's already in the classroom. I did that also for 8.4. So if you want to see lots and lots of examples. But I'm just going to do some examples with you guys for about half the class. Everybody has paper, right? Right. So guys, if you take a note, whatever, right up here, just write, put your name on it, and then turn it in. And I'll give you guys points for that. And what I'm thinking is about the second half of class, so have you guys pull up your laptops and work on this Alex 8384. Right, so check the time here. All right, yeah, we'll do that. All right, so 8.3 common logarithms. So go to 8.3 right here. All right, this is on page 73. Look, now what does common logarithms mean? That means log base 10, which is, of course, one of the two bases that your calculator knows. It's just a regular log. Whenever you see log just without a base expressed at all, it's almost always implied base 10. Right? Yeah, you guys remember that video you were watching yesterday about the history of logarithms? Right, so first guy who was putting logarithms together, here he is right here. You just go back a few pages in the book, John Napier. He started with a weird base. It was like, oh yeah, yeah. Today's. Oh, did I get the date wrong? Yeah. All right. Yeah. Thanks. Good call. It is the 27th. Yeah. Thanks. I do that for Scott. Was right. Yeah. 27. Well, I guess it's 26/7. Yeah, so he was using this weird base of like 0.999 and so something crazy. Okay. But they say, hey, we are using a base 10 system, so that would be easier to work with from a user point of view. Right. And then and it led to this base 10. Right. All right, so we're doing log base 10 here. And I know every day I've been showing you guys this set of rules, but if you know these, you can pretty much solve anything in this module. Right? You can build slowly rolls these out, like one or two per lesson. But it's good, I think, just to see them all up front. Right? So let's do a review, right? And then we'll jump into some examples. Okay? So remember, logs and exponents, you can think of as inverses of each other. Okay? X to the y, z, you can alternately write that as log base x of z is equal to y. Today, we're just going to focus on where that x is 10. So we're doing base 10. So like 10 squared, 10 to the 3, or log base, you guys, okay. Log of 100, log of 1,000. All right. If you have log of two numbers multiplied, you can rewrite that as the sum of two logs. If you have log of division, you can do subtraction of two logs. Log of a to the power of b, you can bring that b out in front and do b log a. Okay? And then change a base formula. So when this becomes relevant, if you have any weird base, you can always bring that back to either base 10 or base e by dividing two logs. Okay.
Will this be, I think I already asked this, but will this be printed with the sheet that we get for each quiz? Like
Okay.
these ones, because I don't think I can remember all of that.
Possibly. I'm kind of leaning towards it. Yeah, I haven't read the quiz yet. Yeah, so I'll get you guys the quiz. I'm looking at end of next week. So be a while. Yeah. So, all right. Here's another couple rules that are pretty handy. Right? If you ever happen to see log base b be to the x, for example, log base 10 of 10 to the 3 is just 3. Right? It's whatever this x is right here. Right? If you saw a natural log, if you see natural log of e to the x, that's also just x. It's a variation of that. Right? Or if you switch this around, what if you have b to the log base b of x? Turns out that's also x. You can show that. Actually, maybe I can show you guys right here. So what if I do 10 to the power of, I'm proving this last one. So do 10 to the power of, and I'll do just log, because that is log base 10, isn't it? Okay. I can type in any crazy number I want. How about pi? Okay. The calculator's got to say, well, pi in this case. Okay. And there it is, 3.141, just like that. Okay. And here's the natural log version. E to the ln x is also. All right, so there's your log rules. Okay. Let's dive into these. Right, so base 10 here. All right, so all the green highlight ones are no longer video, so here, I'll pick some different ones. Let's do, how about do this one, this one. All right, gotta get some story examples in here too. Let's do a wildlife one. Let's try a couple of these. And how about savings? Okay, yeah, so we'll just do those. Okay. No, probably be about half the class. Okay. All right, so use the calculator to evaluate each expression. Yeah, back to for new notes. New notes. And so number 2 just says log of 39. Log of 39. Stick that in. So all you have to do here, can you guys figure out the answer? Everybody's calculated, right? Okay, log 39. Are you guys getting 1.591? The sense in here is 10,000. So I think I need one more digit. Isn't that 4 decimal places? The nearest 10,000? Okay. So if it was phrased that way on Alex, you know, to go to that level of precision. Expect that. Yeah, before I go on to the next one, how can you rewrite this as an exponent? Guys, what's that in exponential form? 10? 10 what? 10.
To the negative 9. No. The 1/39?
To the 1.5911
Oh.
should equal what?
39.
Should equal 39. You guys think that's true? Think it's true? Let's try it out. 10 power 1.5911. Now, of course, we cut this off a little bit. Let's round it a little bit. Yeah, 39. Look at that. All right, number 5. Log of 42.3. All right, well, let's type it in. Log 42.3. I'm looking at 1.6263. Okay. Let's write that as an exponent. How can I write that? Yeah, 10 to the 1.6, whatever, should equal this number. Right? I mean, like, I know 10 to the 1 is 10. I know 10 squared is 100. 42 is somewhere between 10 and 100. That has to work out. All right. Number 10. Solve each equation, round to the nearest 10,000th. So now they're given us 8 to the power of p equals 50. Right? 8 to the p is 50. Right? But there's a few ways you can think about this to grow about this. Of course, there's only one answer for p. Right? Here, before we do that, guys, what's 8 squared? 8 squared is what?
64.
64? And so 8 to the 1 is 8. 8 squared is 64. So p should be between what and what? 1 and 2. It's got to be between 1 and 2. Okay. You guys tell me, what do you think is a good next step?
Log by.
Turn into a log.
Turn to a log. Yeah. Guys, let's take log both sides. And since we're focused on log base 10, let's just go ahead and do that. Let's do log base 10 of 8 to the p equals log base 10 of 50. I mean, isn't that true? As long as I do the same operation to both sides, the equation's still balanced.
Yeah.
Okay. Now what do you guys think?
150.
Yeah, sure. Yeah, you could get a decimal value for this. Let's see what that is. Log of 50. Yeah, I'm seeing the same thing. All right, something like that. Okay. But what we're trying to solve for, it's stuck up here in an exponent. How do we get that out?
Oh, it's a multiplication, right?
Yeah, just trying to send a multiplication. Okay. Wasn't that this log roll right here? You guys remember this log roll right here? Yeah. So we're doing that version. So I'm going to go p times log base 10 of 8 equals log base 10 of 50. So what does p equal to?
Oh.
Log of 50 over log of 8. Isn't that it? That's the whole thing? Okay. Let's see, what is that? Log 50 over log 8. Okay. I'm looking at approximately 1.88 something. Yeah, you said it had to be between 1 and 2. It sure is. Sure is. Let me show you guys something else. A different way to solve that. 8 to the p equals 50. Okay. Because what if you did log base 8? Could I do that? Could I do log base 8 of 8 to the p is equal to log base 8 of 50? Right. Now, the calculator doesn't know base 8, so why am I going down this path? Right. Oh, because, guys, what is this right here? I'm looking at this row right here. You guys remember this row? So what is this? P. Log base 8, 50. So that could also be the answer. Right? But again, the calculator doesn't know base 8. Is there a way you can convert base 8? This one right here? You guys remember this?
Yeah.
Right? Guys. That's right. So P could also be log base 10, for example, of 50 over log of the same base 10 of 8. That could be that. Hey, that is what we got before. It's the same thing. Right? It's a different way to get there. It's the same thing. Right. All right, let's do 13. I got 6 to the x plus 2 is 18. Okay. Trying to solve for x, it's in an exponent. That means a good way to go about solving it would be to apply a what? Logarithm. Oh yeah.
Oh.
Log. I'll do base 10.
Log 18, so then like x plus 2 times log.
Yeah. Bring this down here. All right, so we got x plus 2 log of 6 equals log of 18. Okay, now what? Divide that down. Okay. So x plus 2 is this ratio of logs. Okay. Therefore, x is
Log that.
we have to be like that, wouldn't it? Right, like that. All right, guys good?
Yes.
Wait, one second.
So big on some Steve has
Get a decimal approximation. Log 18 over log 6, then minus 2. Oh, guys, I'm getting a negative number. Is that okay?
No, you cannot. Please don't.
Yeah,
Okay.
Let's see.
That's too.
Yeah, I can have a negative exponent. That's okay. Yeah. All right, so if I do plus 2 and do 6 to that power, it should tell me 18. Yeah, it is. Okay. All right. Okay, let's do a couple story examples. Again, a lot of the green highlight story examples are already recorded, so if you want to watch those later, you totally can. Okay, but here, let's do wildlife. 22, wildlife. The function f of x equals 2 plus 10 log base 9 of x plus 2 gives the estimated number of deer in a county where x is the number of years. So number of years after 2012, and f of x is the population of the deer in hundreds. So I'll say population in hundreds. Okay. A natural resource officer wants to estimate when the population will reach 1,500. Ooh. Determine what year that's going to happen. So years after 2012. Okay. So guys, if we want the population to go to 1,500, then what should I plug in for f of x? 15. Yeah, 15. Because it's the population in hundreds, isn't it?
Oh.
So do 15 of those hundreds. Okay. 2 plus 10. Guys, I got a weird base here. What can I probably just immediately do with that? Can I do log base 10 of x plus 2 divided by log base 10 of 9? Is that okay? Do a little change of base right there. You just did that a minute ago anyway. Okay. All right. And now we need a whole process to solve for x. You guys think we do the algebra solve for x? Here, have it. I'll give you guys a little head start right there. You guys go ahead and start solving that. Reason being, I'm going to type this into Desmos and see what this curve actually looks like. Okay. So while I'm typing this into Desmos, you guys are getting a step or two ahead of me. and then I'll catch up to you guys. Alright, so let's do f of x equals 2 plus and when 10 times log. If you do underscore, you can get a base on the log. So let's do base 9. And then x plus 2. Yeah. Okay. So guys, what does this curve literally look like? Looks like this. Okay. Ah, yes. What was this, a deer population or in hundreds? So it looks like in the year 2012 there were like 515 deer. Do you guys see that? Okay. And then as the years progress, the population is growing, but at a slower and slower rate. Okay. Yeah, so that's what we're looking at. All right. Did everybody subtract 2?
Yes.
To say 13 equals 10 log x plus 2 over a log 9. Did everybody divide by 10 and times log 9?
Yeah.
So log of x plus 2 equals 13 times log 9 divided by 10. Okay. Guys, what's the next step? This x is buried inside a logarithm. How do you get x out of the logarithm? How do you undo a logarithm?
It's a multiplication, right? Like log x times log.
Okay. If we have this and you're trying to solve for x, is this like a kind of shorthand version of what we're trying to do? Can we turn this logarithm back into an exponent? Right? Okay. I think that's the only way we're going to unbury this x out of this logarithm, is to turn this back into an exponential form. Okay? That's it. Let's say, and now this is log base 10 right here. So I'm going to go x plus 2 equals 10 to the power of this crazy fraction right here. 13 log 9 on 10. Right, so crazy exponent. Okay. And then to get to x, all I have to do is subtract 2. So 10, 13 log 9 on 10, and the whole thing minus 2. Okay. Now, I'd like to get a decimal approximation of that. This is an exact answer. Okay. And then we'll go over to that Desmos graph and see if that actually lines up. 10 to the power of 13 log 9 on 10, whole thing minus 2. I'm looking at 15.4, it rounds to. Remember, this is hundreds of deer. I think it was deer, right? Yeah, hundreds of deer. So if I plug in 15.4 for x, then f of x should. Whoops, no, sorry. Guys, that's not. Oops. Guys, that's not hundreds of deer. I'm getting silly. Like, what is that?
The years.
Yeah. Yeah, this is years after 2012. Okay. So 15 years after 2012, what year is that?
2077.
2027. Yes. It's 1 year before the year after next year. It's next year. Next year. Okay. Let's see. So should show up as 15.4, right? Let me try that. Let's go x equals 15.4. Okay, so again, that's years after 2012. Okay, and that should correspond to a population of 1,500 deer. Isn't that true? This is in hundreds, so it should be 15 about. It is. It's right there. It's that gray dot. That's exactly the coordinate I was looking for. Yeah, it's right there. And so math is working. Yeah. All right. Let's hit these two down here, and then one more story example. Number 30, and then we'll close the notes. Okay, number 30. Express each log in terms of common logarithms. That's to say base 10 logs. Then approximates value to the nearest 10,000. So we have log base 6 of 5 to the 4. Here, I'll write this way a little bit. Actually, you know what I really want to do before I convert bases? What do you think I'm going to tell you guys to do first?
Move the four from the log and then.
Exactly. Right, I like that idea. Yeah, let's move the 4 and right.
And then convert it?
Yeah. So we have log base 6 of 5.
I have to get to now.
Right. So now, what goes in that fraction? Whatever, what?
5/6 log.
Yeah. Log 5 over log 6. And now these logs are of course base 10. Okay.
Wait, wouldn't it also be like 6 to the power of 5 equals whatever?
Well, okay. So what you're thinking of is because if I set this equal to x, right?
Yeah.
All right. And what if I went about this a different way? So I'd have to okay. See, this is already set up to solve, so really I just need to convert it. Okay. But if you did any algebra switching, you would be like bury what you're trying to solve. Okay. Like you could say x over 4 is equal to log base 6 x of 5. I mean, that would be a true statement. It just doesn't really help you solve for x. Okay. And you could do 6 to the power of x over 4 is equal to 5. Big N, that doesn't really help you solve for x. Right? Maybe it helps you create a puzzle. You do that. Right, so let's get a decimal approximation here. So this is 4 log 5 over log 6. I'm looking at 3.5930 it rounds to. Okay. All right, guys ready for next one?
Yep.
Number 33. We got log base 2 of 3.6 to the 6. I think this looks pretty similar, doesn't it? Here, give you guys a head start. Go ahead, stay a step ahead of me. Beat you to the answer. So there's my first step. There's my next step. Actually, I think that's the answer right there. Okay. Is that what you guys got?
Yeah.
And let's do decimal approximation. All right, approximately 11.08 80. Like that. Okay. That look good? Of course, you could plug. Okay. Right, last one in the notes. Last one in the notes. 41 savings.
41.
All right.
It's like 6, 7, but it's 41.
Oh, we're doing 41 now?
Yeah.
All right, 41. Why not? The equation t equals 1 over log 1 plus r gives the number of years it takes for $1,000 to grow it into $10,000 in a savings account at an annual interest rate of r. Okay. If Joe wants to grow her account from 1,000 to 10,000 in 45 years, determine the interest rate needed. Okay. Well, basically, we're solving for this interest rate, given that t is equal to 45 years, right? And everything else just falls in place. Okay. I want to show you guys why this question is showing up in this particular lesson. Okay. You guys remember something like a equals p times 1 plus r to the t? Right. So accumulating interest in a bank. Guess from that. Okay. Now, in module 7, usually I would give you the principal, the interest rate, and the time, and ask for what's the amount after so many years. Something like that. It's pretty classic setup. Right. Some version of that. Okay. But what if you want to solve for time? Right. What if you want to solve for time? Now what you're solving for is in the exponent. So the only way to properly do this, again, with like not nice numbers, is with logarithms. Because I can rewrite this as a log. I can say a over p equals 1 plus r to the t, and then take the log of both sides. Log of a over p equals t times log of 1 plus r. I brought the t down. Okay. And now you can solve for the t. You guys see that? Okay. And so that's probably why they're doing this here. So let's say 45.
Wait, sorry, Mr. Griffin, could you go back to that?
It's right here. Yeah. Okay.
So it's a over b equals 1 plus r.
So what I'm trying to do is solve for how much time does it take. like if you put in a principal of $1,000 and say, hey, I want this to tenfold to $10,000. Okay? How much time is that going to take? And of course, that depends on the interest rate also. Okay? So the algebra steps are they divide the p over, okay, and then take the log of both sides. And after you take the log of both sides, then you can pull the t down, and it looks like this. Okay? And then the amount of time it takes to reach whatever level you're going for would be log of a over p, which you could also write as a difference of logs, all divided by a log of 1 plus the interest rate. That would draw. Yeah. Okay. So here's something like that. 45 is 1 over log 1 plus r. We are solving for, determine the interest rate. Yeah, so we're solving for what's the necessary interest rate so that she can tenfold her money in 45 years. Like, how much interest would you need to for that to happen? Okay. What do you guys think the next step is? Ooh, this may be a creative way. Guys, can I take the reciprocal of both sides? Can I do that?
Yeah.
Okay. So I could say log of 1 plus r is 1 over 45. I mean, that would be true. What's the next step?
Multiply by 45.
Let's convert to an exponent. The reason I'm thinking that is because what we're trying to solve for is buried inside a logarithm. How do you get that out? Let's do 1 plus r is 10 to the power of 1 over 45. Therefore, r is 10 to the 1 over 45 minus 1. Okay. And decimal approximation, what is that? That's 10 to the 1 over 45, then minus 1. Let's see, did I do that right? 45 years. He is 45. That'd be true. That'd be true. I'm getting a weird answer, but all the steps are right. Okay. Okay. Yeah. So I don't see any error with that. You guys. Yeah. So it's giving me a negative answer. Let's do this instead. Right. So your book is saying it's like 5 point something percent. Right. I think what's messed up is this original expression. So what we're going to do is actually let's just play off this because we've already solved it like this way, haven't we? We've already solved it. Okay. So we're solving for we're solving for r. Okay. So let's follow this right here. Let's go $10,000 compared to $1,000. That's a over t. Is 1 plus r, and we need 45 years to pass. Okay. So it's at 10 equals 1 plus r to the 45. Okay. Now I can take log 10 of both sides equals log 10, 1 plus r, and those 45 can of course come in front. Okay. Log 10 and 10 is 1 equals 45 log of 1 plus r. Okay. 1 over 45 equals log of 1 plus r. 10 to the 1 over 45 equals 1 plus r. That same thing? Oh, I know what it is. I put this on my calculator wrong. Oops, I think. Yeah. That okay. Sorry guys, that was my fault. I put this in the calculator wrong.
All good.
So actually this is fine. 1045 minus 1. Okay. So this comes out to 0.0525. Yeah. Okay, that's what the book was saying. Okay. Now that's as a decimal. So guys, what is that as a percentage? 5.25%. That would be. Okay. All right, so that worked out. All right, so you guys got rest of class to here, do this. Make sure your name's on your notes. Turn in your notes. I'll give you guys points for those. Okay. And then you can either work on Alex or you can watch one of those uploaded videos.